Okay, good afternoon, class 9 students. How are you today? Good afternoon. Everybody is fine? Yes or no? Okay, everybody is fine. Now today we are starting new chapter. Okay, we are starting new chapter. Do you know what is the name of the chapter? Classification of elements. I think this chapter was already discussed some portion. So today we are continuing it. So let me check what is today's discussion. Today's discussion is about these things. Now it has come on the screen. You can see now. It is being displayed. Okay, students. Did you see something on the screen? Let's begin. In today's class, we will be discussing about atom, next structure of atom, afterwards subatomic particles and their charges. Afterwards we will be discussing about subcell, cells and different types or examples of cells, subcells, etc. Alright students, at first let's begin from atom. Atom. Last time we discussed that there are 118 types of elements. They can be categorized into metals, non-metals and metalloids. So metals, that is the element which is good conductor of heat and electricity. Non-metal is bad conductor of heat and electricity, and metalloid is semiconductor of heat and electricity. So all the atoms are made up of only one type of smaller particles, and those smaller particles are atoms. Now let's define atom. What is the definition? The smallest particle of an element which takes part in a chemical reaction without its division, without its breaking down, is called an atom. Here we have to keep in mind, atom is smallest particle, takes part in chemical reaction, it does not break. Very interesting one, right? So how many types of atoms are there? There are 118 types of atoms, because 118 elements, 118 types of atoms. Like if you give example, oxygen. Oxygen is made up of only one type of atoms. Nitrogen is made up of another type of atoms. Helium is made up of next type of atoms. Atoms of one element is different from another. They are not alike. Okay students, next thing we have to keep in mind about structure of atom. Dear students, look at the diagram. What is shown? One spherical body is shown, and it is written beryllium atom. Beryllium atom, right? And at the center you can see smaller particles, and it is marked as proton and neutron, and there is one spherical body is shown as nucleus. Outside body is cells, and in that cells there is presence of electron. So atom is very small body. It is not visible through our naked eyes. it can be seen through a very, very powerful microscopes. We have to use very powerful microscopes, and it is spherical in shape. Atom is spherical in shape, and diameter is near about 10 to the power minus 10 meter. 10 to the power minus 10 meter. Earlier, scientists believe that atom is not further divided into smaller particles, but John Dalton, he gave one theory in 1806, and he said an atom is made up of smaller particles. We say atom is the smallest one, but atom is also made up of smaller particles. They are called subatomic, elementary, or fundamental particles. The smaller particles present in an atom are called subatomic, elementary, or fundamental particles, basic particles. What are those subatomic particles? Number 1, electron. Number 2, proton. Number 3, neutrons. EPN, remember, EPN, N. E, electron. P, proton. N, neutron. So, these particles may be less in number or more in number present in an atom. Some atoms contain less number of neutron, proton, electron. Some contain more. Okay. On the basis of presence of number of proton or electron, the elements get atomic number. So here we have to keep in mind their location. Proton is located at the center of atom, which is called nucleus. Neutron is located at the center of an atom, that is called nucleus. It means at the nucleus there are two types of particles, proton and neutron. Dear students, protons contain positive charge. Remember, protons contain positive charge. Neutrons are chargeless. They don't have any charge. And electrons are found in the cells outside of the nucleus. They possess negative charge. Electrons, negative charge. And electrons revolve around the nucleus like the planets go around sun, isn't it? In the same way, electrons go around the nucleus. So you have to keep in mind, electrons are lighter particles and protons and neutrons are heavier particles. So lighter particles, they can go around, heavier is difficult over there. Now here is given one thing, what is that? Characteristics of subatomic particles. Electron, we write E minus, proton P plus, neutron N0. Why 0? Because neutron has no charge. And electron lies at cell, proton and neutrons, they are present at nucleus. And their mass is not expressed in gram because they are very lighter bodies, very, very light. And their mass is equal to like this. Electron 1 by 1837 AMU. What is the full form of AMU? Atomic mass unit. Proton 1 AMU. Neutron 1 AMU. And if you talk about charge, electron minus, proton plus. Students, let's discuss next thing. What is the relation between gram and AMU? Very simple. 1 gram equals to 6 times 10 to the power 23 AMU. It means if 6 times 23 times, if 6 times 10 to the power 23 protons are combined together, that will be equal to 1 gram. What about charge? Charge is expressed in coulomb, COULOMB. So 1 coulomb equals to 6.25 times 10 to the power 18 ESU, or 6.25 times 10 to the power 18 electrons. So what do you think? Electrons, they possess more charge or less charge? One electron contains less charge, but if there are groups of electrons, they contain more charge. Dear students, an atom contains positively charged particle proton, negatively charged particle electron, but it is charged less. An atom is charged less. Why is an atom charged less? Because the number of protons and the number of electrons are equal. Positively charged bodies and negatively charged bodies are equal, then it is chargeless. Let's learn one thing. Phosphorus is an element. When it comes in contact with air, it burns itself. Sometimes in our villages, we hear people claiming to have seen a ghost burning a torch. They say Rakebut. Okay, what do they say? Oh, I have seen Rakebut, which is complete cult of fire ghost, Rakebut. The burning is caused by the phosphorus of the bones of release from dead animals, which changes into solid phosphorus due to different chemical reaction. The solid phosphorus comes in contact with oxygen to burn. During daytime also, phosphorus burns, but we cannot see it. But during night time, it can be seen. Anyway, that was do you know. Students, now let's discuss next heading. What is that? Next heading is cells, subcells and orbitals. Okay. Keep in mind, at the center of the atom, there are presence of protons and neutrons. Outside, there are electrons. And the electrons, they revolve around the nucleus in a fixed path. And that path is called cells. What's the definition? The paths traced by electrons around the nucleus are called orbits or energy levels or cells. Electrons, they revolve around the nucleus in fixed path. That path is called cell. So the cells are written as K, L, M, N, O, P, Q, etc. K, L, M, N, etc. But one thing keep in mind, all the atoms do not contain these K, L, M, N, O, P, Q, R. Small atom contains, there may be presence of only one cell or two cells, but a bigger atom contains more. I mean to say, the atom of hydrogen contains one cell, the atom of oxygen contains two cells, the atom of calcium contains 4 cells, etc. But if you talk about atoms of uranium, it may contain 6 cells. Okay? Why? Because electrons are found in different levels. All electrons are not found in one place. There is some reason. Area. In some area there are found some electrons, some numbers, and again a bit far away, next numbers. And they are called energy levels. What do you call them? Energy levels. And we represent those energy levels by using the number 1, 2, 3, 4, 5, 6, 7, etc. And this idea was given by Bohr, one scientist named Bohr. Okay? And students, let's discuss next thing. The systematic distribution of electrons in different cells is called electronic configuration of an atom. Let me repeat. The systematic distribution of electrons in different cells is called electronic configuration of an atom. It means all the number of electrons are not kept in one place, they are distributed systematically. In one region, some number of electrons are found. In next region, another number of electrons are found. And in next region or area or space, next number is found. So, suppose an atom has got 20 electrons. All electrons are not found in the same place. They are divided into different regions. For that, some scientists are there who give idea how to find out the distribution of electrons. The formula is 2n square.
Excuse me, Ishwar Sir, Vishnu Sir is calling.
2n. So there was minor disturbance. Now we will be discussing further ahead. So where were we? We were in cells, subcells and orbitals. And I was saying, there is one formula to calculate the maximum number of electrons that can be kept in K cell, L cell, M cell, N cell, O cell, P cell, etc. And it was given by two scientists, Bohr and Bury. So it is called Bohr-Bury scheme. Remember the formula? 2n square. 2, it is fixed. N means number of cell. Like first cell, K cell, N is 1, L cell, N is 2, M cell, N is 3, and N cell, N is 4. For example, to calculate the capacity of K cell, use the formula 2 times 1 square. It comes 2 times 1 equals to 2. And next one, 2 times 2 square, it is 8. Means the capacity of first orbit is, or first cell is to hold 2 electrons. Second orbit is to hold 8 electrons. In M, how many can be kept? 2 times 3 square means altogether 3 to the means 3 square is 9. 9 to the 18. So 18 electrons can be kept in M cell. And what about N cell? We can keep altogether 2 times 4 square means how many? 32 in that way, 50 in that way, 72, it goes increasing. Okay friends, now let's see next thing, what is here? Alright. Sapna, did you write something of today's lecture? Show me your video first. Sapana, can you hear me? So this study material study is very important. You have to make note. If you make the note, it works. And only making note is not sufficient. You have to revise time and again. So time to time, revise it and place in your copy. Practice. Keep on practicing. Then it will be quite better. Okay? Lockdown time, we have to utilize with better effort. So, students, now you see next one here. The last person I just said, the ability to hold the electrons, the capacity to hold the electrons in K cell, L cell, M cell and N cell is given here 2, 8, 18, 32, etc. That's why according to the number of electrons present in atom, they have got number of cells. For example, if there are maximum 2 electrons, there is one cell, that is K cell. If there are electrons up to 10, then there are 2 cells, K and L. If up to 18, then there are 3 cells. In that way, we have to memorize the electronic configuration. Students, look at here one diagram. What is shown here? Energy number is 1, 2, 3, 4, 5, 6, 7. Name of the cells: K, L, M, N, O, P, Q. Cells are given there. And maximum number of electrons are accommodated in different cells according to 2n square, 2, 8, 18, 32, etc. So from this diagram, what can we make the rules? Here are some rules. This diagram shows the information, distribution of electrons, and the rules are: first rule, the cell nearest to the nucleus is K cell, which can contain only 2 electrons. Maximum 2 electrons in K cell. Second rule, the outermost external cell cannot have more than 8 electrons, and next to the outermost cell can contain maximum 18 electrons only. So in outermost cell there will be maximum how many? 8 electrons, and afterwards there will be 18. 2, 8, 18. It is not necessary for a cell to be completely filled before the next cell starts filling it. In actual practice, a new cell begins when the outermost cell gets 8 electrons. For example, 2, 8, 8, 1. Actually in third there must be 18. There should be 2, 8, 9, but not that way. 2, 8, 8, 1. About that we will be discussing in one heading, that is electronic configuration in terms of subcells. Students, we came to know that there are different cells like K, L, M, N, and these K, L, M, N are further divided into smaller regions. They are subcells. So there are mainly 4 types of subcells. They are S, P, D, F. 4 subcells. Cells K, L, M, N, O, P were subcells SPDF. All cells do not contain all subcells. Some they contain few, some contain more. So S contains, means case of the cell contains only S orbital. L contains S and P, M contains SPD, and F contains SPDF. Four types are there. So K, S only, P, that means L, SP, then M, SPD, and N, SPDF. So remember, look at here, four types of subcells, SPDF. So DF, these subcells also can carry fixed number of electrons. S subcell can carry 2 electrons. P, maximum, I am saying maximum, in S 2, P 6, D 10, and F 14. So remember 2, 6, 10, 14. And here we have to give example, like if there is S orbital in K, then it is written as 1s. For L cell, we write 2s and 2p because there are two subcells. In M, 3 subcells, 3s, 3p, 3d, and N, 4 subcells, 4s, 4p, 4d, and 4f. In that way, it keeps on going the things. Okay, students. So today's class is over. Please make note and do your best. So tomorrow we'll be meeting at the same time with new topic. Till then, thank you. Have a good day. Bye bye.